My name is John Mead, and I'm with Cellar Ridge Construction, and we're here today to talk about the Passive House project that we have going for the Pitney residents in McMinnville, Oregon. We're very excited about this project. There are 1,000 things that we do different to make a house meet the Passive House standards, and so we're here to talk about a few of those things. So let's start with the envelope. The envelope of the house is the insulated area that surrounds the living space. And so for this project, our envelope is our walls coming down to the slab where we have 12 inches of rigid foam insulation underneath the slab, coming up into these 10-inch deep walls that are thermally broken by framing two walls, a 2x4 wall on the exterior of the house and a 2x4 wall on the interior of the house. And by separating this framing, we eliminate the thermal bridging that would take place in standard construction. Outside of this 10-inch cavity that will be filled with dense pack fiberglass insulation is a 3-inch layer of Roxul mineral wool insulation for a total of 13-inch depth of insulated wall cavity. Moving up the envelope at the top in our attic insulation is R70, 2 feet of fiberglass blown-in insulation. At the Pitney Passive House project, we've installed a utility chase at the ceiling of the project. So rather than having just trusses and the ceiling be open to the trusses above, we've actually installed 2x6s with OSB sheeting on top of it. On top of the OSB sheeting, we have more blue skin. So that's the top air barrier for the project. Inside of the 2x6s, our utility chase allows us to run our wiring, our plumbing, our ducting for the heat recovery ventilator, all within that space so that we can minimize the number of penetrations that go through the ceiling and into the attic. Okay, welcome to the attic of the Pitney project. You'll notice some distinctive things about this attic. First is the floor of the attic is the blue skin. We talked about that earlier. This is the air barrier for the house. And we have to be very defensive in building a passive house of the air barrier. And so every time there's a wire penetration that went through our air barrier, we asked our electricians to hang a red flag so that we would know to come find that wire and air seal it. And so they ran their wire, and rather than going a straight line, hard angle to the hole that that wire goes through, they actually left us a little bit of a loop that allows our wire to go directly through the sheathing and the blue skin at a 90-degree angle. And around this wire, we've applied the butyl tape to air seal this wiring penetration. And again, on the other side, we've filled the hole around the wire with silicone caulking. Okay, so air sealing is a huge deal with Passive House. So a standard house that's built to code will have an ACH, air changes per hour, of around 6 to 7. With a Passive House, we need to achieve a 0.6 or better air changes per hour. And that's a measure of how tightly the building's been constructed. And the test is a blower door test, where they put in a fan, evacuate the air out of the constructed building down to 50 pascals, and then measure the CFM air leakage to calculate the air changes per hour. So this house that we built, our preliminary blower door test achieved a 0.51, which we're very excited about. But to achieve that, we had to be attuned to the minute details of paying attention to the air barrier, to the ceiling, to the window installation, and attend to many, many details to make sure that we could achieve that air tightness for this project. So our primary air barrier for the Pitney project is Henry's Blue Skin, which is our weather barrier and air barrier applied to the exterior of the sheeting of the house. We are really excited about this product. We've had some phenomenal success. One of the benefits of the Henry's Blue Skin is that it has a sticky back, so a clear plastic film that we remove apply it to the sheeting, pressurize it. Let me give you a little demonstration of one of the reasons that we're pretty excited about the blueskin and how it performs. All right, so a cup of water, and then we apply the blueskin to the cup of water. Don't stick it to itself. And as you can see, we get a seal that is watertight for the blueskin. The really exciting thing about the blueskin is that it is self-sealing. So in other words, every fastener that we put in through the blueskin, when we're putting up siding, when we're putting up our rain screen, it is self-sealing. And so as you can see, there's no water leaking. So every time we run a screw, a nail, a fastener through that blueskin, we maintain that airtightness and, more importantly, that weather barrier to keep rain out of our construction. So as you can see, every fastener is self-sealing, but if we pull that fastener out, here comes the water. So that leads us to a very important part of our construction is sometimes during construction, when somebody puts in a screw or a nail, we have what's called a shiner. And those people who know construction know that's when a nail or a screw's missed the stud that we're shooting for. In fact, we have an example of a shiner right here. And so what's critical with Passive House, with our blueskin, is it's absolutely essential that our construction workers do not remove the shiner. So if they miss the stud, we ask them to leave it because we don't want a hole that's going to allow air and water into our envelope. So with Passive House construction, we have to be absolute fanatics about every penetration through our envelope. And so here is an example where we have an exterior light on the outside of the house and two wires running out to that light, one to power the light and one to daisy chain over to the next light over. And so where these wires run out through the blueskin, we use a butyl tape product from Henry's company to seal the wire on the outside. At Cellar Ridge, we're a firm believer in the belt and suspenders approach when it comes to air sealing. We want to be certain that we've sealed every penetration. So on the inside of the envelope, where the hole goes through for the wires to reach the outside, we apply silicone into that hole to create an air seal on the interior to couple with the butyl tape on the outside of the building. So for the insulation in the main walls, for the interior section of the walls, we do blown-in fiberglass. And so the first step of that blown-in fiberglass is to staple up the cloth onto the interior studs. And that will get stapled with a staple literally every 1/4 inch throughout. And then each bay will be slit and fiberglass is pumped in under pressure. And the beauty of blown-in fiberglass insulation, dense pack, is that it is almost impossible to get wrong. When they pump this cavity full of insulation, every wire, every electrical box, every penetration, every little detail will be filled to the brim under pressure with that fiberglass insulation. Much superior to fiberglass batt insulation that is almost impossible to install with a complete connection to every surface within the wall cavity. Just because of the nature of it being a blanket, a batt, that you have to cut and carve to make it fit into the wires and other things that are in the wall, it's almost impossible to install fiberglass batt insulation properly. It's almost impossible to install blown-in dense pack fiberglass insulation incorrectly. So we're big fans of the robustness of this insulation system. So he's going to blow that into a density that fills every little nook and cranny. You can see as he's blowing in the dense pack fiberglass insulation that's held in by the fabric netting, he's going to fill that cavity until that cavity has been pressurized to a certain level. Fills every little nook and cranny. one of the reasons that we are fans of fiberglass insulation is that the material, by its very nature, is inert. It is not relying on a secondary chemical treatment to make it impervious to pests and water damage. There's never going to be a pest, a rodent, an insect that's going to want to eat this fiberglass. If moisture gets into it, it does not rely on other products to keep it from molding. And so just by its very nature, it's inert. Again, we like the robustness of that approach.
What is the product?
So the product is fiberglass, and it's made from spun glass fibers. So you can see here, this cavity that's been blown in with fiberglass, it actually has some pressure to it. It's been densely packed, and that helps us assure that proper installation that we're after. So you can see here, this is the wall between the house and the garage. And most houses don't treat that wall any differently than other interior walls. But for our passive house, we need to understand that this is part of the envelope, and we have to treat this wall exactly the same as we treat the other exterior walls of the house. So we've wrapped it in blue skin and maintained a very good air seal between the house and the garage. And then we've added our Roxul insulation. So Roxul is a product that's made from spun basalt. So it's actually a mineral wool. It's very hydrophobic. In other words, it'll shed water and creates the exterior portion of our insulation package when combined with the fiberglass inside. That's how we get to our R50 insulation value. So our exterior insulation, Roxul mineral wool insulation, is installed by placing the 3-inch thick panels of Roxul against the house and then actually fastening them to the house with our rain screen. So we've got 1x4 Doug fir battens fastened with pretty hefty screws, and so each screw goes in and needs to land on a stud. And if they miss the stud, then they have to leave it. And so they did a pretty good job with their accuracy, but this is what creates our rain screen and installs our Roxul insulation. So down here you will see our foam insulation. So underneath the slab we have 12 inches of rigid foam insulation. Coming up and around the sides we have 4 inches of rigid foam insulation that actually served as the form boards of our concrete pour. So one of the tenets of green building and certainly applies to passive house, because we've air sealed this house so tightly, there needs to be a mechanical system to bring in fresh air and to exhaust out stale air. And so for this passive house, we've gone with a very high quality approach with a Zender heat recovery ventilator. And this heat recovery ventilator is going to exhaust stale air out of the house, and it's going to bring in fresh air from the outside, and it's going to use the heat from the air inside the house to preheat the fresh air coming into the house through a heat exchanger. The distribution ducts for this Zender system are actually these little tubes called Compo tubes. They're each 3-inch round, and so they're corrugated on the outside, gives them some strength and rigidity, but they're smooth on the inside, so it has very low resistance to the airflow that comes through these. Each room will have either a supply or a return, and those supplies and returns have been sized to either be 1, 2, or 3 Compo tubes to each register, depending on the requirements of each location. This is our pre-wiring for the range hood, and you'll see the wire here. What you won't see is a duct going to the outside. We were able to apply for an appeal to the building department at the city of McMinnville and use our heat recovery ventilation that will be running 24 hours, 7 days a week to be the only ventilation that occurs in the kitchen. So this is an appeal. We used the exact words that Dylan Lamar from Greenhammer used for the city of Portland. So shout out to Dylan and the folks at Greenhammer for their pioneering work. We at Cellar Ridge have been inspired by some of our friends in the building industry that have really pushed passive house, and so Hammer and Hand in Portland and Green Hammer, that's a shout out to them because they've done some really fantastic work over the last years pushing the passive house movement forward. So thanks, guys. So sometimes a passive house is characterized by what it has, and sometimes a passive house is characterized by what it does not have. And so this is another case where you will not see a dryer duct coming out of this laundry utility construction. We've asked our client, in order to help achieve the air tightness that this passive house really needs to have to meet the certification, to use a condensing dryer. And so all of the humidity from that drying process is condensed into liquid water and runs down the drain, pumped out to the washer drain. So the Zender heat recovery ventilator utilizes the Comfo tubes, and in this particular room, the ventilation demands called for 2 tubes to this register, and so those tubes slide into the manifold with a little bit of special lubrication, and then are clipped into place to maintain that air seal. And then the register comes down. We will install our sheetrock around this tube, cut off the tube flush with the sheetrock, and then install the register cover. Very critical decision in the life of a passive house is windows. And so there's a lot of thought put into the location and sizes of the windows, as well as the manufacture of the windows. So for this project, we used Intis windows, and these were manufactured in Lithuania. And they're made from unplasticized PVC, and they're very high quality windows, you'll see. These are a tilt-turn window, and so they're able to tilt in for ventilation and security, or when you know how to operate them, turn in to allow a great deal of air movement in and out of the house. So you can see the thickness of this window. It is a triple pane window, and the thickness of the glass is remarkably thick. So they've created insulated a gas-filled space that's pretty deep, and that's how these windows achieve the insulative value that they do. Part of the passive house design is to work with a certified passive house consultant who goes through the design and actually comes out to the job site, does a solar finder at each window location before we've even broken ground, to determine how much sunlight will be coming through each and every window, so that we can model how much solar gain will be coming through each and every window in the house. With that design, with that window design, we've focused a majority of the glazing on the south face of the house, where we're bringing in light. Even the best windows, such as these that meet passive house standards, are still much less insulative than even an average wall. And so those windows need to be used strategically, and by placing the majority of the glazing on the south side, we're actually getting more heat energy out of the sun and passive solar heating than we're losing through the insulation of the windows. So the windows for this project are actually energy creators, energy generators for the project. So this window in the bedroom is an east-facing window, and so we've minimized the glazing size on some of the other walls so that we can maximize the glazing on the south side. Okay, so here you see an extravagant amount of glass, and this is on the south side, and so we're actually getting heat, passive solar heating. Part of the energy model was to locate outside of these windows every tree and to determine exactly how much sunlight, how much shading will occur every day of the year at this specific location. So in addition to being super energy efficient, our clients have decided to install solar panels for this house. And you've heard of net zero houses that create as much power as the house uses in a year. They've actually decided to go beyond net zero, and they're going net positive, and they're going to produce enough electricity off of their solar array to power the house throughout the whole year and power their electric vehicle as well. So here in the garage we have the end point of the solar, and so we've ran conduit up that runs all the way out to the rooftop where the solar array will be installed. And you can see they've got a pull string, actually a pull ribbon, for when they're ready to run their conductor from the inverter for the solar array up to the solar panels. Another unique aspect of the Pitney Passive House project is the Rainwater Collection that they've asked us to implement for them. So we have a metal roof coming down to sealed rain drains that will run out to 3,000 gallon tanks in the backyard. And so not only will this house be a net positive energy house, they will supply all of the water, domestic, irrigation, potable, non-potable water will all come from the rainwater collection that's done on the house. So net positive energy and net zero water consumption for this residence. So an important part of rainwater collection is the gutter guard. So we have a very fine micro mesh stainless steel gutter guard that has been installed under the metal roofing and over the top of the gutter. And this does the majority of the filtering of leaves and debris that come off of the roof, and this gutter guard keeps that stuff out of the rainwater collection tank.
So with us here we have John Pitney, who owns the passive house that Cellar Ridge Construction is currently building in Minville, Oregon. And John, if you have a few minutes, we'd like to ask you a few questions.
Absolutely.
Fabulous. So what made you and your wife, Debbie, decide to build passive?
It was easy. We've been working on sustainability issues in our communities and through our churches for 30 years, and we've made it halfway to net zero in our last house in Eugene and in our church. And so it's like, now we're retiring, it's time for us to go all the way. And with everything that's happened in the world, Paris summit just now, it's time for people who can to step up and help the countries of the world meet their climate agreements.
So this doesn't sound like it was a decision that you both made on a whim. It's something that you're very passionate about and have lived out through much of your life.
Absolutely. It's like we're retired. We'd love to have been able to do it before, but now we can. And at this point, it's like it's something we wouldn't not do. Just that's the way it is.
Excellent. Now, what made you choose Cellar Ridge Construction to build a house?
Because the staff was so handsome. I was just really, frankly, I think I Googled green builders McMinnville, Oregon, and Cellar Ridge came up. And on the site it showed the 50-50 homes or whatever that was. And I talked to John Mead on the phone right away and said, so we're moving. Think we could build a passive house? We're just talking really small. And he said, sure. Said they hadn't done that before exactly that way. And so that was pretty much it. I mean, first conversation, I didn't need to talk to anybody else.
So we were hoping to hear a shared passion for green building, but
It's the good-looking people. That's all that matters.
I looked at their profiles online. That was helpful.
Yes, exactly. No, I mean it was so good to so easily find somebody who was already here in McMinnville doing it, because along with making the net zero itself, it's also important for us to use local workers.
What made you decide to take the extra step and incorporate a rainwater collection system?
Well, kind of the same as the other. I haven't worked, and Debbie and I have not worked with water issues and water things as much as solar. Solar's kind of old hat to us anymore, but really wanted to try a rain catchment system, and so I started studying that, and there's a lot of people putting in little colorful rain barrels and that, but we wanted to do something really substantial, and for both the net zero project, energy project itself, and the solar things, building right in the middle of town where people can easily see it, and we can take kids through, classrooms of school kids through, and people from the neighborhood, and I'm really excited about the rain thing because it's the newest part for us.
And now tell me a little bit more about how you'll be utilizing solar power.
So in the net zero scheme of things, beyond passive house, the way to reach net zero is to have your own energy generation, from some source. So we've been using solar for a long time, and the solar panels that we're using are actually a newer technology. They've got a 20-year warranty on them, and I think they'll be fine after 50 years. So it helps us make it all the way to net zero, and we've actually gone a lot beyond net zero, because what we had said to John in the beginning was we don't want to just handle the load in the house. We want it to be the load in the house plus how much it would take to charge our electric car for a year. So that's the fascination of it for me. For us, this is seriously in response to climate change. Beyond the fascination of just doing it ourselves, it's everybody has to make changes in our dwellings, residential and business. It's exciting to see this happening in the world. I think it's a chance for us to get ahead of the Germans.
This passive house is the pot of gold at the end of the rainbow for them.